Hello to everyone. My name is Oriol Angurell. I come from Leitat, technological center in Spain. My background is an organic chemist, and I've been working there for the last 3 years and a half. And now I'm the scientific coordinator of the project Nefertiti, which is the main topic of today's course. We will start making a general overview of the project and seeing the different chapters that we will discuss. And yeah, I've prepared here a general overview. We will go through each chapter very quickly and make a brief summary of what we will discuss in each of those chapters. So starting for the first one, the first chapter will be about the challenge of photochemical systems, and more precisely the Nefertiti approach, what we will do in the project. So we will view the general picture of the project, and we will see how we aim to transform this water and CO2 into ethanol in this case, using only the sunlight. So once we present the general project, we will go into details and see what does each partner and which are the different key factors that will provide us success in this general goal that we have to obtain ethanol. The second and the third chapter will be related into the first photocatalyst. The project Nefertiti is divided in two different reactions. The first one is to transform water and CO2 into syngas, and the second one is to transform this syngas into ethanol. Then in the third chapter we will see a little bit more of details and results of this photocatalyst, and how is the efficiency and the advantages of this photocatalyst compared to the other ones that are in the literature. Then after that, we will move into the second reaction, and we will make a little state of the art of different catalysts that are nowadays available or published, let's say, that transform this hydrogen and CO into ethanol. So we will make a big picture of the literature, what is nowadays available, and then in chapter 5 we will see what we are doing in Nefertiti, or what we will do during the project, which are the advantages of this photocatalyst, and how we approach this reaction, because it will not only be a normal Fischer-Tropsch reaction, but also photocatalytic reaction. After that, we will go into chapter 6. Here we will talk about anchoring techniques. Here in Nefertiti, the reactions will be carried out in flow using the flow technology. And for that reason, we will try to anchor this photocatalyst into the internal walls of the reactor. So we will see here different techniques to anchor both photocatalysts in each of the reactors. Then in chapter 7, we will talk about in silico design and characterization of novel catalysts. Here we will see more a theoretical approach, and how do we model this photocatalyst to know more details and to predict how they will behave into the reactor and if they will be effective or not. So this is an important key to keep improving the design of both photocatalysts. Then in chapter 8, we will see how these reactions will be performed, so over which photoreactors will we work. We will develop two different photoreactors, one for each reaction, and we will see how are they designed, the microchannels that are inside, and yeah, all the details and how they are made. Then in chapter 9, we will talk about luminescent solar concentrators. These are normally organic dyes that can increase the efficiency of the reaction by concentrating the light, and what they do is they absorb a certain wavelength and they can emit in another one, so we can concentrate the light using these light harvesting systems. Chapter 10 will discuss and will talk about the evaporation membranes for the ethanol purification. So here we will see, once we get the ethanol, how we can purify it from the reaction mixture, and how we can separate it from the water mostly. So we will prepare a evaporation system, and we will see how much ethanol we can isolate pure from this mixture. Chapter 11 will be about integration, validation, and scaling up. Here we will test all the system in a really small scale reactors, and then we will try to scale it up to 10 times, and also try to do the reactions outdoors using real sunlight. So this will be a real challenge. And finally, the last chapter will talk about safe and sustainability. And we will see here the insights of the toxicological analysis that we will perform to ensure that these photocatalysts and all the reactants are not harmful, neither for the environment or for all of us. So thank you all for your attention, and I hope to enjoy and to learn a lot from this course.